Namaskaram everyone. Welcome back to the 42nd episode of our Master Unreal series. And in this episode, we are going to go back to our interaction system use cases. So this time we are going to implement the push the box interaction. And this is the first part of it where I will show you how you can determine in which direction your character is facing with respect to the interactable. So for example, if there is a cabinet placed in front of you, you can determine whether your player is facing the front, left, right or back. And based on those directions, you can define different type of interactions. And you can also restrict the interactions from the sides you don't want. So for example, if you want to push, we only want to allow the pushing from front or back. If you are standing in left or right, the interaction will not be allowed. So if you haven't seen the previous episode of interaction system, I recommend you do that because certain elements were already there. We are going to reuse them and we are going to derive this new use case in this interaction system of ours. So without wasting any time, let's get started. So for this, you will open the content drawer. In the architecture, we had this bench and door. Just create another folder, call it cabinets. Open it up, import this cabinet. This mesh is available on Discord. You can download it from there. So I'll double click on it, import, and you will have all these 4 meshes. So let's save all. Okay, now we'll create an active blueprint for this cabinet. Double click on it, select these 3, drag it inside the default scene root, and here you will get your drawer and the cabinet. Now here these 3 drawers are same, so instead of having these 3 identical meshes, we will just have one and we will duplicate it. So what I'm going to do, I'm going to delete these 2 drawers and then it will ask that it is being used in this cabinet, so we will replace it with drawer 1. So drawer 01, replace references. Okay, save selected. And now if you open it up again, go in viewport, and now you can drag it right here, then the third one to this point. Okay, so there you have your 3 drawers. Great, now you just press file and save all. You can also rename this to drawer instead of 01. Cool, now let's make it interactable. So as usual, we will go to the class settings. In the implemented interfaces, I'll add BLI_interactable, compile, and in the event graph interfaces, we will have all the functions. Cool. So now let's start implementing. Hold interact, get hold time. So we will say 0.2 seconds is implemented to true, compile. Then we have the set highlights, interrupted over is available to interact. So for this, I will right click, promote it to a variable, and we will rename it to B boolean is allowed to interact. Okay, compile and then double click on the on interact function. Now here we don't have any such thing, so we will leave it as false. So we have the declarations with us. Now let's start the implementation. So as soon as we receive the hold interaction, we need a montage. So in the characters, mannequins, animations, actions, you will find this folder of box. This includes the start, stop, and the pushing state. It is consistent and it is part of the same animation. So this is a very good thing for us. So for this, we will create a montage. So I'll right click on the push start and create anim montage. And we will rename it to am_push interaction. Okay, press enter, open it up. Now, like we did in the previous video of the bench, where we created 3 different sections to manage the start, loop, and the stop, we are going to do the same thing here. If you want to be precise, you can also name it box push interaction instead of push interaction, just to make it more specific. Great. Now let's add the animations. So here I will go for pushing. Okay, so first we will add this pushing UE right here. Then we need the push stop. So let's drag this one. So we have these three. Now let's mark these sections. So the time of this is 4.73. So right click in this section line, new montage section, idle start, and let's change its timing by going in the details. Okay, this is on 4.73. Let's create another section, right click here, idle end, and this one will be here. Okay, so we have these sections. Again, if you want to know the details, what is the reasoning, what is the logic behind the naming and all that, check out the previous episode of bench interaction. You will get everything. Great. So this is a easy part. Now let's save it and we can move this into montages. Okay, so we have our box interaction. Great, now we can compile this, go back to cabinet, and now we need to implement these. But let's do the simple things first. We will call on interaction interrupted from the BLI receiver, so that receiver gets notified. Then we will go for this one, on interact over from BLI receiver. Once these two are done, we will allow the interaction again. So let's bring this and set it to true. So once is available to interact is allowed, and then you press on this hold interact, you cross the threshold, then we have to start the implementation. So we will check whether it is allowed to interact or not, because this hold interact will be constantly called if in case you want to show progress bar and all that. So we do not want to re-trigger the logic of pushing the block again and again. So that's the reason we place this branch node just like we did in the bench interaction. Okay. So once this check is passed, we will say on interact and we will go for call function. That means the event or the function that is present inside this actor, that is B cabinet. You can also see the target. Great. Now let's place it here. R, and plug it. So in the on interact, we will make this is allowed to false because now some actor is interacting. Now we need to position the actor. So in the last two interactions, we have been constantly copy pasting the code. So this time we will just create a generic function. So I'll go in the content folder of mine and I'll search for BP generic functions. So this is the blueprint function library that we created in the inventory management. In case you don't have it, you can go for blueprint function library and you can create this one. Okay. Once you open it, you can create the functions. So I'll go for position actor and we will go to our bench position actor and we can copy this code that we created. So we will copy this and then we will go to generic functions and paste them here. Okay. And now who's the target? We will accept here and let's name it actor or target actor to be more precise. Change this variable to target actor. So get target actor from the variables, connected this, connect with this, and remove this one. Okay. And now we need the scene component. So source scene, and we will name it to scene component, object reference, and this one to actor. Great. We can also rename this function to position actor to scene transform to be really more precise. Okay. So now we will plug the target actor here and this one, let's delete it, get the source scene and plug it here. Great. So this takes care of all the situation and make sure this is target actor. Good. Now compile. There's some issue. Let's remove it and check it. It is actor. Let's get target actor, then connect it like this. Compile now and we are good. Also, we need to take these two inputs in the input. So I'll pass them here, and disconnect these. Rename this to use controller rotation. Okay. Now we can plug these pins here. So get use controller rotation to this pin and get disable free look to this one. Okay, now it is generalized and every interactable can use it instead of copying and pasting the implementation again and again. Okay, so before we go back to our cabinet, this Z value is completely dependent on the type of interactable. So in the door, you were able to open from the two sides, if you remember. There are two different case scenarios. Like in the door, you were able to open it from both the sides, but in case of bench, you were only able to interact it from the front side. That is basically to sit. So the rotation of the character is controlled by this Z, the yaw. So this is something that is completely dependent on the type of interactable you have, because if there is a two-way interaction possible, like at front or back, then you have to check where the character is standing. If it's a single way, like a bench, then you have the front. Our case of cabinet is having all four sides. So in that case, we would like to know from where he's trying to push the cabinet. Is it front, back, left, or right? So that's why I took this example, so that you can have all kind of calculations in this generic function, and you can control the interactions from all the four directions. So this Z value, we will take it from the actor who is trying to call this. So we will create another input, actor yaw. Okay, and we will change this to float. So whatever yaw will be there, we will use it here. Great. Rest of the things are okay. So we will compile. Great. So we will go back to cabinet, and here we will position the character. So we will create a function, position character, and here we will use that function. So position actor to scene transform, and we'll connect this. Now we need the target actor. So the target actor is coming from here. That is our instigator, or you can also name it player. I will say player because you can only push the bench or you can break it. So there's no other kind of interaction happening. So of course it will be player. So we will not use instigator this time. It's very confusing. Great. So we have player. Then we have source scene. So we need to create the source for all these four positions. So I'll create four scene components. One, that is the front. Then we will just duplicate this one and name it back. Then we will duplicate it again, call it left, duplicate again, right. So you can push it from all four sides. Compile. Now go back to position character, and now we need to determine which one to send. Apart from this, when you are trying to push the block, we would like to disable the controller's rotation, and we would like to allow the free look, because you should be able to move your mouse when you are pushing, okay, just to look around. And then we need the actor yaw based on the position. So for this, we will go in generic functions and find facing direction of player with respect to actor. Okay, and you can give some spaces to make it more clear. Now here we will expect two locations, and let's rename it to player. Change this to actor object reference and go for target actor. You can also make it generalized by saying of source with respect to target actor. Okay, so find facing direction of source with respect to the target actor, and the player is our source and the target actor is the cabinet in our case. Okay, so go for these namings. Good. Now, how do we calculate that? So when it comes to the front or back, we calculate the dot product with the forward vector, which I explained quite in detail. And the left and right is determined by the right vector. Okay. And this is the forward vector, the facing one. So what I'll do first, I will get the normalized vector. So for this, I'll take this source actor, get actor location. So this will give you the world location of this. Do the same for this one. And then we will subtract, and then we will get the normalized vector. So normalize. Okay. So you have the result. We can promote it to a local variable, and we can rename it normalize vector. Good. Now once this is done, we will compute the dot products, and we will use branching. So we will go for a dot product, and we will promote it to a local variable, and we will say forward dot, and then we will create another variable, right dot, and let this be float. Okay, so let's connect it here, and now let's get the target vector all the way from bottom and get the actor location and connect it all the way here. Good. So this will give us the forward dot. Now we need the right dot as well. So let's bring it here, and let's duplicate this dot, plug it here, normalize vector, and then get this one. So we have the right dot as well. And what we can do is just duplicate, connect it here and here. Now we can go for a sequence node just to keep things organized. So once this is calculated, I will go for a branch node. Now here, so first thing we will check is the forward dot, whether it is greater than 0.6, and the right dot absolute is less than 0.5. Again, this is something that is connected with trigonometry. Whenever you compute the dot product, there are different angles. So the ideal angles, or the angles that we talk about usually is 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Okay. And the 45-degree value is like almost approx to 0.7. So we will consider 0.6. So this is how I came to this value. And why this 0.5 is because it will not be always precise. Sometimes it can be like 0.65 or 0.69 or 0.68. So in such cases, it is still facing the front. So that's the reason we made it 0.6 instead of 0.7, and then we check this 0.5 in the right dot so that we can cover that minor error that can happen. So we will check this if this is true. So if you're following the series, you will have this enum locomotion. Let's type locomotion. Yeah, the locomotion directions. You can use this one. So facing direction, it is nothing but an enumeration. So let's go for a return node, and we'll say it is a forward. So you have forward, backward, left, and right. So if you are not following the series, you can just create an enumeration and keep these 4 options. Okay, so this is for the forward. Good. Now let's go for the backward case. So I'll go for a branch node again, and I will duplicate this, connect it here, and this time we will change this to less than minus 0.6 and keep this absolute right dot as it is. We go for return, and this is a backward direction. Great. Now we need the left and right. So I'll go for a sequence node here, and then I'll connect this one here, break this pin. Great. Now let's duplicate this entire logic, place it here, and connect this pin to the dent. Okay, so first you go for this one, then front, then back, and then you go here. Now here we will do left and right. So this time we will use right dot here. So right click on this, replace variable with right dot. So instead of disconnecting or connecting, you can right click and change the variables. So right dot greater than 0.6, forward dot less than 0.5, and if it's so, then it is right. Okay, and this one is left. The correction here is we change this to right dot, this one to forward dot, this one remain less than minus 0.6, and the absolute is less than 0.5, and this one is left. Okay, so compile. So you have the facing direction. Now let's test it. So what I'll do, I'll go in the cabinet, event graph, and in the event tick, I will use my player, get player pawn, and find facing direction. So the source is our player, target is the cabinet. So get reference to the self. And let's do a print string and connect it. Oh, my bad. I forgot that I have to use the forward and the right vector to do the dot product. I accidentally did this. So let's remove this. This would be the forward dot. I don't know what I was thinking. Great. So let's get the target actor again. Get target actor. I was thinking of some other case and I almost forgot. I have to get the forward vector and then plug it here. Then we have to get the right vector. So for this, I will go for get right vector of this target. Okay, and now if we play, you see it says right. Then this is the forward, this is the left, this is the backward. Okay, so this is because how we imported our mesh. If we go in viewport, usually the facing direction is in this side. So what you can do is add a scene component that is your cabinet. So first let's rename this to structure, cabinet structure, and this one to, first you have to hit compile, then rename it to cabinet. And now you can drag all these four inside this. Now what you will do, rotate it in this direction. So this is the actual facing direction. If you have observed in your third person. Okay, so now if I play, this is the right, this is the front, this is the left, and this one is the backward. Okay, great. So make sure the facing direction in Unreal, it is in the right side. Okay, so I'll go back to my cabinet and make sure you do not rotate this in your scene. If you want to rotate this in some other direction, always apply the rotation on the cabinet like this. Okay, now if you do this, and now if I go and play, you will still see the calculation is correct. This is the forward, this is the backward. Okay, so never apply the rotation on the scene component, always apply on the main actor, because we are using the actor's location, rotation and scale most of the times. So what I'll do, I'll go and reset this. So now we have the correct direction being predicted, and now we can remove this. So now you know. So when the interaction happen, you have to position the character. Okay, so we are going to remove this and this one as well. Now here we will use that function, find facing direction, plug it, get player variable, and get reference to the self, plug it here. And then we are going to promote it to a local variable, facing direction. Once we have the facing direction, we can call this position actor to scene transform. Get these two duplicates. The target actor is the player. Source scene is something we have to make a choice. For this, we will get these four Put them here. Get the left and right to the bottom and the back one here. Great. Now we can use the variable facing direction. Go for select. And now you can plug the pins forward, backward, left, and right. Now this would be the source scene. And now we need to get the world rotation. So get world rotation, split it, get the Z, that is the yaw. Okay, so now we compile and then we will allow the interaction by default. So select this, make sure this is set to true. Okay, and we will call this in the on interact. So let's go to the on interact, call this position character here. And the instigator is our player. Now when the character is positioned correctly, and let's set the positions, this select the front, move it somewhere here. Let's call it 85 and the rotation should be in that side. So I'll rotate it in minus 180 degrees so that the character will be facing this side. Now we can take the back and let's push it here. Let's do minus 115. Then we go left. This should be the left, minus 156. And we have to rotate the character at this side, so 90 degrees. Now take the right. Let's make it 95.5. Rotate it in minus 90. Okay, so you have right, left, front, and back. Hit compile. And once the on interact is over, we would like to end the interaction. Right now, we are not going to play the montage. So I'll just say on interact over, which is inside the call function. That is our cabinet. So let's pass the instigator and make sure you are doing print string and just print the facing direction. And also make sure the cabinet meshes are set to block all. So select all these 4 meshes and make them block all so that you don't walk through it. If I compile and play, sorry for this change in scenery. This part is recorded a little later. So if I hold E, you can see it says forward. If you go in the back, it says backward, and you are positioned as well based on the scene component that we place. Like if I go like this in a little angle, hold E, you are in the forward direction. So once this is done, now we can add the animation montage. So I'll go for play anim montage. So now we can remove this. And now we need the skeletal mesh component. So this is our instigator. Let's get the skeletal mesh, which is part of our interface, that is BLI character. I'll connect this, plug it here, and the on interaction over will be called on the on completed, and on interaction interrupted will be called here. So on interaction interrupted. Okay, and let's select the montage from characters, mannequins, animations, actions, montages, and this is the box push interaction. Select it and press this and it is inside this one. Great. Now if I compile and play, hold E, you can see it is trying to push. So we go back to the cabinet and we detach this because we are going to require it little later. Now we need to set the notifications so that we know when to push. But before all this, the primary reason of putting this interaction episode after the 2-bone IK was that if you play the game and hold E, you can see my hands are not at all on the cabinet. So we have to position them. So to position them, we have created the function in the interface that allows you to update the IKs. So this is the update IK factors that we created in the previous episodes of the equipment system. Okay, so now we are going to use these two to update the hand IK position. And another thing that we want is like we should be able to push it from front and back, and we do not want to allow pushing the cabinet from left or right. Although you can try all four, but I will also tell you how you can allow interaction from only from front or back, or for that matter, any side you want. So I'll take front and back because the cabinet's width is very less. So we will go to our cabinet, and in the is available to interact, we will check first whether you are allowed to interact or not. And then we will also check whether your position is in the front or back. So in the position character, we are using this. So let's copy this node, go in the is available to interact, place it here. We want the player. So is available to interact needs to have the player as an input. So we will go to our interactable in the content, open this up, and in the is available to interact, we will create a variable, name it instigator, and it should be of type actor object reference. Now if you compile and go back to cabinet, you will find the instigator pin. So you can disconnect this, go for a branch node first. If it is available to interact, then check in what direction is it. And if it is not, then you can just return false. That means it is not available to interact. But if it is available to interact, then we have to make sure that you are standing either in front or back. So we will remove this, and then we will promote it to a local variable, name it facing direction. And then we will check if the facing direction is equal to forward or boolean, then duplicate this and then go for backward. So only if you are standing in these two directions, then we will say true. Otherwise we will say false. We don't need that branch node. So if the interaction is allowed, then go further. If not, then return it. And the source actor is our instigator itself. So let's connect this pin. And then we will check if you are standing in front or back. And then we will go to our gas, that is third person, blueprints, abilities, interact. And here we were checking whether it is available to interact or not. So we will pass the instigator. So for this, I will get this function here, pass this pin here. So this is our player. Now if I compile, and actually I renamed them incorrect. This should be right, let's say, and this should be left. Let's correct this as well. So at this point, the interaction is cancelled. It is not even begun. So in that case, we would like to notify the receiver that the interaction did not happen, but you are still in touch with the interactables. So that means they should be able to press and hold again. So what I will do, I'll go to my BLI receiver and I will create another function on interaction denied. Okay, so when the interaction is denied, we would like to be notified. So this is useful when you want to enter into a zone and the barrier stops you from going inside, or the door does not open. So in that case, it just says denied. So in that case, you might want to do something. You might want to trigger a cutscene, or you might want to trigger a dialogue or something like that. So we will not take anything in input because it is not needed. And we will compile, go back to our third person. So first let's go in the third person, and you'll find on interaction denied, double click on it and notify the BPC interaction manager. So the interaction manager is here, and we will create a custom event. We will call it on interaction denied, the same event name. Okay. And now here we would like to reset the tap count so that the entire interaction loop can start from 0 again. Remember, it is not interrupted nor it is over. It is denied. So the tap count is already 1, but now we have to reset it. So I'll go here, connect it, compile, go back to our third person character, get our interaction manager, and we will call on interaction denied. Okay, Now if we hit compile, now we will go to our gameplay ability and we will go to our activate ability. So let me remove my logs. Okay, this is good. So now there are two places where the ability did not even perform its action. One is here, second one is here. See how easy it is to figure out the positions. So what I'll do, I will call a custom event and I'll say on interaction denied. Give some space. So first I will get the avatar actor from actor info. I'll first notify. So interaction denied, that is from BLI receiver. Then we would like to end the ability. So let's end the ability. Okay. So instead of calling this end ability, we can delete this and we can call on interaction denied. Remember to call it here, this one. The call function means all the functions that are listed in this class. So we'll call this one, not the receiver. And delete this, plug it here. Okay, we are all set. Compile, play. Hold E from the right side, nothing will happen. If you go in the forward, hold E, it works. Okay, so this is how you restrict the movement. Save all. Alright, so that's it for this video. I hope you enjoyed it. This was the first part of this push interaction where you determine the direction. So in the next episode, I'll show you how you can move or adjust your hand based on the height of the interactable. So in this case, the cabinet height was small and our hands were little upward. So we will pull them down up to a point where we want them to be placed. So in the next episode, I'll show you this, how to place your hand at the exact point which you can predefine in the actors. Okay, so if you haven't joined the Discord, please find that link in the description and join, and you can collect all the assets from there. And like the video, share it with your friends, subscribe to the channel, and do let me know if you have any comments or suggestions. And if you like the work and want to support on Patreon, the page link is in the description. Please do reach out before buying any membership. So take care. I'll see you in the next episode. Bye.